Hello and welcome to Math Lessons with Linda. Today's topic is ellipses, and you can see that we have our first equation right here. So let's get started. It is x plus 2 squared over 64 plus y plus 4 squared over 4 equals 1. In an ellipse, the two denominators are going to be different numbers, and your equation should always be equal to 1 before you begin. The first thing we would want to do is figure out the center of the ellipse, which we're going to take the opposite of these constants inside of our parentheses. So the x coordinate is -2 and the y coordinate is -4. So we know that the center is in quadrant 3. Now, an ellipse is different from a circle because an ellipse is sort of like a circle that has gotten smushed. So it's either going to be tall and thin, like this, or it's going to be short and wide, like this. So we have what's called a major axis and a minor axis. The major axis is the one that is the longer of the two. And for an ellipse, whichever fraction has the larger denominator, the variable above that, that's your major axis. So in this case, our major axis is x. That means our minor or shorter axis is y. The value that is the denominator for the major axis is an a squared value. So in this case, a squared equals 64, which means a equals 8. That number is important when we get to graphing our ellipse in just a moment. The minor axis, which is the y, has this b squared value underneath, which is 4. And that means that b is equal to 2. Again, something we're going to use when we are graphing our ellipse. So at this point, we can go ahead and start making a sketch of what our picture is going to look like before we move on to find other values. So since I want to be in quadrant 3, and I have a really long value for my x-axis, I think what I want to do is make my graph so I have a really big spot over here for my center and then for my other values. If you have graph paper, that's probably a little bit better, but for right now, I'm just gonna sketch it. So the first thing I want to do is graph my center. So -2, -4 is right down here. And we're going to have a lot of points on this graph, so you may just want to label things with one letter so you know what you're talking about. So here's my -2, -4. Now, my major axis is parallel to the x, and this 8 that we found means that I have to go 8 spaces to the right from my center and 8 spaces to the left. So that's where the end points of my major axis would be. So I'm going to go 2 back over here, and then I'm going to go 6 more, and that'll give me my 8. I'm going to do the same thing here. I'm going to run a little bit out of room because I've got to go to -10. So that's right around here. And then for the minor axis, I do the same thing from the center. I go up 2 spaces and down 2 spaces. And if you need to, you can find the coordinates for all of these points just by adding and subtracting the 8 and the 2. So I'm now going to just sketch what my ellipse looks like. So I can tell that it's short, but it's very wide. Now, inside an ellipse, there are 2 points called the foci. And these points are represented by the variable c. And there is a formula that we can use. It looks very similar to the Pythagorean theorem, so don't get those confused. And it is this: a squared equals b squared plus c squared. Now, we already have the a squared and the b squared. Remember, 64 for a squared and 4 for b squared. And so here's my c squared. So I get 60 equals c squared. So c is the square root of 60, which if we're sketching these points, we actually need to have an approximation for the square root of 60. It's about 7.7. So what I do with this c value to get these foci points is I go back to my center, and this time, instead of going 8 both directions, I'm gonna go 7.7. So they're gonna be really close to your endpoints. And the foci points are always on the same axis that's the major axis. So I have to have them along here. I'm just dotting this so we remember that's our major axis. So 7.7 away would be very, very close over here. I'm gonna put F because it's a focal point. And then over here, I've got another one. So once we have the center, all of our major and minor endpoints for those axes and our foci, we have finished graphing an ellipse.